at the time right now, so let's go ahead and start.
Sounds good.
Yeah, I can see 20 people already joined. So good afternoon, everybody. Happy Wednesday. So welcome to today's online event called Bidirectional Contract Testing. So as usual, before we get started with the content today, I'd like to go over some of the notes on how to participate on today's session. So the duration of this session will be around 1 hour. The speaker will be presenting 40 to 45 minutes, followed by a Q&A session, 15 to 20 minutes. So if you have questions to our speaker, we ask you to please address it through the chat anytime during the presentation, or wait till the Q&A session at the end of the presentation, and our speaker will try to answer to as many questions he can during this event. Also, I'd like to remind everyone that today's presentation will be recorded, and we will be posting all the recordings to our YouTube channel. For those who couldn't join the call, or anyone who wants to rewatch the session and make notes from the presentation, you can do it so in our YouTube channel. So now, without any further ado, I would like to introduce our speaker for today's session, Bas Dijkstra, joining us from all the way from Netherlands, from a beautiful city called Amersfoort with a great history. He's a director at the Inspired Academy. In this role, he is creating and delivering training opportunities for Inspired testing staff, as well as global customer base. Prior to this role, he's been active in the test automation field for more than 15 years now. He started first as an engineer, but more recently, he's working as a trainer and a consultant. He delivered test automation training to the wide range of companies and conference attendees in the Netherlands as well as abroad. And he will share some of his experience with us today. So really excited to have Mr. Dijkstra with us here. And without any further ado, Bas, why don't you go ahead and take it away from here?
Awesome. Thank you so much for that wonderful introduction. So yeah, good morning, good afternoon, good evening for all of you, depending on where you are. Again, with all of these remote online sessions, it's just good day. Let's stick at good day. That works for everybody, really. Yeah, I'm not going to talk about whoever that I couldn't have done it any better than the introduction you just gave me. So let's dive right in. So the topic that I want to talk about with you today is contract testing, more specifically bidirectional contract testing. But before we dive into bidirectional contract testing, I want to tell you a little bit about what I sort of refer to as the traditional way of doing contract testing, the problems that it tries to solve, but also the problems that it brings with itself. Because the traditional consumer-driven contract testing approach has its downsides too, its hurdles. And that's the reason why bidirectional contract testing came to be in the first place. So first of all, just a little bit of context and background. So recently, a lot of companies, organizations, IT systems moved from these big monolithic structures to services or to applications that are much more distributed. Maybe even microservices based, where we have these loosely coupled components where each component has its own responsibility, and these components talk to each other, talk to one another, communicate with one another, exchange data, often through APIs, and together, and when they're all nicely stitched together, they perform some kind of business process. And the big question with these distributed systems, one of the big questions when we're doing integration and end-to-end testing is, are all of these individual components and services able to communicate with one another at any point in time? Because these components can be developed in different development teams, in different departments, in different organizations, maybe even different continents. So integration and end-to-end testing typically becomes a lot harder. But this question is no less relevant. It's maybe even more relevant in the more distributed your system becomes. It's not just does each of those individual components work as per the specification, but also can all those components together when communicating, can they talk to one another, or can they successfully exchange data to support some kind of higher level business process? So we used to traditionally do this, test this the Big Bang way, testing integration of everything at once. And where we tried to create a test environment where all of those components are in the right place, in the right state, with the right data, all at the same time. And the more distributed your system becomes, the higher that is to maintain, the higher that is to achieve in the first place. So contract testing is an approach that tries to deal with that by breaking down the puzzle of large-scale integration and end-to-end testing into small manageable pieces. So instead of looking at the integration of everything at once, it's going to look at the integration of individual consumer and producer, or consumer and provider pairs. So instead of are A, B, C, and D all able to talk to one another, it's going to check, is A able to communicate with B, is B able to communicate with D, and is B able to communicate with C. And it tries to simplify that process even further by making the process asynchronous. Where traditional integration end-to-end testing is synchronous, meaning all of the components need to be in the same test environment at a specific point in time, because they all need to be connected to actually exchange data and messages. And that's just a pain to set up, to maintain, and to run your tests. The contract testing way, integration and end-to-end testing using contracts, is asynchronous, meaning that any individual consumer and provider do their part, perform their part of the integration testing flow as part of their own build cycle. But at no point do a consumer and a provider actually have to be in the same test environment at the same time. And so it breaks down that puzzle even further by saying, well, if consumer A needs to talk to provider B, they don't even need to be in the same test environment at the same time, because we have contracts. So the way tooling, and more specifically Pact, works is that the traditional flow is consumer driven, meaning it's the consumer that generates the contract, the consumer that and from that contract, Pact generates a mock provider that can be used to test the implementation of the consumer. But that contract is also a list of expectations that a consumer has on how the provider behaves. And so it's the consumer's responsibility to specify those expectations, to generate the contract, and to then distribute that contract to a provider. That provider can then pick up the contract. From that same contract, a mock consumer is generated, which will be used to invoke the actual provider implementation. And Pact can then check, well, the responses that are returned by the actual provider, do they match the specifications, the expectations that are specified by the consumer in that contract. And so basically, to summarize this, we have an API consumer, we have an API provider, we've got a broker in between, so a repository that manages and versions the contract, and that stores contract testing verification results. And the traditional flow looks like this. So first, a consumer generates and publishes a contract. The provider downloads the contract and verifies whether or not it can fulfill all of the expectations. It publishes the verification results, and finally, both the consumer and the provider can check those verification results and see if it's safe to deploy a new version into production. This is the traditional consumer-driven contract testing flow. Let's look at that quickly, what it looks like in practice. So I've got a little project here with 2 consumers and 1 provider. Think of these as being implemented in the context of a web shop. So I have a consumer that deals with order data. I have a consumer that deals with customer data, and both customers and orders may have addresses associated with them. And so an order has a delivery address and a customer has a billing address, or just a residential address. So both the customer consumer and the order consumer, they depend on the address provider. So I've defined some tests here in the traditional Pact way with expectations about what a response body might look like for different paths. So for existing address IDs, for non-existent address IDs, for incorrectly formatted address IDs, and the same for delete operations, for example. And if I run these tests on the order consumer side, what's going to happen is, first of all, it tests the implementation of the order consumer itself, but it also generates a contract that can then be published to a Pact broker, and then at some other point in time, I'm going to do that right now, but not publish, there we go. This publishes that contract, so a list of all of the expectations that the order consumer has to the Pact broker. And I'm going to do the same now for the customer consumer, because a contract is an agreement between a single consumer and a single provider, which means that our address provider has to fulfill expectations over 2 contracts, one for the order consumer and one for the customer consumer. I'll publish that as well. There we go. And this is my Pact broker, Pact broker, my repository of contracts. And if I now refresh this, it takes a little bit of time to load, unfortunately. It takes a little bit longer than I expected, but it's going to get there. There we go. And we have 2 integrations, 2 contracts that are, as of yet, both unverified. So this is the consumer part of the consumer-driven contract testing flow. Now it's time for the address provider to prove that it's able to fulfill all of the expectations that are in the flow. I'm going to do that by, again, saying maven clean, and then I'm going to set a flag pact.verifier.publish results, set it true. So this command downloads the contracts from the Pact broker. It checks the implementation of it checks whether the actual implementation of the address provider is able to meet all of the expectations that are set in the contracts, and it publishes those verification results back to our Pact broker. So that too takes a while, and for some reason, the first time it always indicates 4 passed tests and 4 skipped ones. Which I've learned we can safely ignore, because it will actually do all of the checks and upload all of the verification results. I just know, I've run into this before. It takes a while. There we go. So it says test run 4, skipped 4, which is not actually true. That's, by the way, that's only the first. So in the meantime, I'll run these tests another time, and you'll see that after these ones are done, it actually says, well, 10 tests passed, which is much more in line with what I expected. But more importantly, let's have a look at whether or not these all of the expectations that are specified in the content or written down in the contract can actually be fulfilled. And as we can see, both for the integration between the customer, consumer, and the address provider, as well as the order consumer and the address provider, it's a success, meaning the address provider is able to fulfill all of the expectations for both these contracts. Or in other words, there are no identified integration issues between any of these three parties. This is the traditional consumer-driven contract testing flow. And so this is the way people typically implement consumer-driven contract testing using Pact. If you want to just have a read up on contract testing in general, on Pact, on the code that I've just shown you, this link is the first in a series of 6 blog posts that I wrote on contract testing with Pact in Java that actually uses the code base that you just saw on screen. And that gives you a nice overview of the contract testing process, the different components that I introduced, and all the kinds of things that you need to do to set up contract testing. But at this, let's call it traditional way of doing consumer, the full-blown traditional consumer-driven contract testing approach, it has some implementation challenges. And these are not just implementation challenges that I've experienced. These are implementation challenges that the whole contract testing community and the people that developed Pact and Pact Flow themselves have also experienced with their clients. First of all, using Pact requires teams to write tests. And for me, probably a lot of you are working in testing and say, well, of course we are going to write tests. However, not all teams, not all development teams are so aware of the usefulness and the need for writing tests. So the fact that they need to write actual tests might seem a little bit scary for them. So, oh no, that's a lot of work. We're never going to do that. So that's hurdle number 1. Also, there is some coupling between the consumer and the provider here, and by means of the states. And by states, I mean, as a consumer, I need to specify, no, I don't want to refactor. I need to specify the state here. So a specific situation and that specific situational path in my API flow is probably linked to some kind of setup and some data that I need to set up at the provider side. So there's some, and to some extent, there's coupling between the states that are specified by the consumer and the states that need to be implemented by the provider, which that doesn't always scale really well, and especially not if you have a large number of consumers that all consume the same provider API. That provider API needs to manage a lot of states and a lot of different situations, and that doesn't always scale really well. And this is one of the reasons that getting provider teams on board can be quite difficult. And because there's a lot of use in consumer-driven contract testing for the consumers, convincing provider teams that contract testing is actually useful and beneficial and can have a lot of value is more difficult sometimes. Because a lot of the benefit is consumer-centric. And also and especially, and this is especially true, and this is where consumer-driven contract testing doesn't even work really well, is when you've got public APIs. And where providers basically say, well, this is my specification, this is my behavior, now you go deal with it. I'm not really going to change anything. In that case, getting provider teams on board is not only difficult, it's sometimes even impossible, because, well, they just do what they do and you as a consumer just have to deal with it. And also because of the nature of these tests and the way they are so closely tied, as you probably also quickly saw in the example, it's quite closely tied to the implementation of the consumers and providers, which mean that it's something that's very close to what developers work with on a daily basis. But getting testers on board can be a lot more difficult because it's a lot of code. It's closely tied to the implementation, which is not always within the boundaries of the comfort zone of testers. And of course, that doesn't apply to every tester. There's lots of testers that are more than happy and willing and capable to do this. But generally speaking, it's more difficult for a lot of testers to get on board and to get involved in contract testing the traditional way. And so these are some of the things that over the last couple of years, when people started implementing, and some of the hurdles, the difficulties, the challenges that they have run into. And that's why the people behind Pact Flow came up with a new paradigm, a new way of doing contract testing through bidirectional contracts. Quick disclaimer, so there's two flavors of Pact brokers. So there's Pact Flow, the one we saw, which has a free plan but is a commercial product. And there's the open source Docker-based Pact broker that you can download. That's again completely open source, free, and but that you need to host yourself. The feature that I'm going to show you, and just bidirectional contract testing in general, is Pact Flow only. So it's only supported by Pact Flow and not by the open source Docker-based Pact broker that you need to host yourself. So again, this is the traditional way of the traditional flow. We saw that before. The bidirectional flow is simpler. And it's simpler in the way that it's not the consumer generates a contract which is passed to the provider. Now with bidirectional contracts, well, it's all in the name really. Contracts come from both ends. So there's a consumer that generates their contract, and there's a provider that also generates and publishes their contract. And instead of having a contract generated by the consumer and given to the provider, both parties generate and publish their own contract, which is then checked on for compatibility by the Pact broker. And again, this is a Pact Flow only. Only the Pact Flow Pact broker can do this. So it's no longer the provider's responsibility to prove that it can match all of the expectations, meet all of the expectations from the consumers. It's the Pact broker's responsibility now to check for compatibility. So that's a simpler and quite different flow from the traditional way of consumer-driven contract testing. And of course, once that compatibility check is done, both the consumer and the provider can check those compatibility results and see again, well, is it safe to deploy using the Can I Deploy tool in Pact? So that hasn't changed, but the flow just got a little bit simpler. And what the beauty is of bidirectional contract testing is that instead of specifically using Pact and writing code that at the consumer side that specifies expectations, contracts can be derived from existing technology and tests, which means that if you already have a form of a contract in place or a form of tests in place, you can use that to generate a contract and then upload that generated contract to the Pact broker. So you don't need to spend a whole lot of time and work to actually implement Pact and write all of the specifications and write the associated tests. No, you can leverage existing tests, which are maybe tests that you as a tester have already written. So they can be rest assured based tests, they can be Postman based tests, they can be Cypress based tests, they can be tests that use WireMock as a mocking tool, for example. And those are tests that teams typically already have in place, which can then be used and can then be upgraded to also generate a contract that can be used for contract testing. So let's see how that works in practice. Let me quickly switch to a different branch. There we go. Take IntelliJ a little bit of time to catch up. But what this branch contains is a fourth component called a payment provider, which was not in the main branch. This payment provider is a provider to the order consumer. So orders and customers have addresses. But if you have a web shop, it's also probably a really good idea if you provide some form of payment or an option for actual payment of your orders. So there's an integration or a dependency between the order consumer and the payment provider. And so now the order consumer has two providers. So it still depends on that address provider to provide it with address data, but it now also depends on the payment provider. That payment provider is a public API. And again, with public APIs, implementing the traditional way of contract testing is often really difficult because, well, it's a public API. It's just going to do what it does, and that's it. But luckily, this payment provider does have a static type of contract. It does have an open API specification, which is also a form of a contract, a form of a specification of how that API behaves. And the team that's responsible for developing the order consumer will likely already have some tests in place that test the payment service, that depend on the payment service. And in this case, and what you often see, especially with public APIs, they don't rely on an actual implementation of that payment service, of that payment provider. They mock that out. And in this case, they've mocked that out using WireMock, which is a popular HTTP mocking tool for Java. So there's no, for this integration, the integration between the order consumer and the payment provider, there's no Pact. There's no Pact-based tests. The only thing we have had to add, or I have had to add in this example to enable contract-based testing is there's nothing I need to change on the payment provider side, because for the payment provider, its open API specification is going to be its contract. For the order consumer, these tests, these integration tests against the payment server that use the payment service provider were probably already in place. And they probably, it's likely that they've already used WireMock. And the only thing that has changed here is that I've added a mock service request listener here of the type WireMock Pact generator. This is an adapter, or not an adapter, rather a listener that I can add to WireMock, which listens for incoming requests and the responses that are used in return to those requests, and during test execution, and it generates a Pact contract, a consumer side contract from those interactions. So it's not specification based, it's based on what is actually being the request response, the traffic that's actually going back and from the web to and from the mock when the actual tests are run. So these are just typical tests that would probably already have been in place before people even started contract testing, because they did integration testing already. So the only thing they will need to add is this listener to their existing WireMock instance, which again, they would probably already have had at their disposal. And now if I go back to the order, so nothing has changed for the customer consumer, so forget about that. If I now run the tests for the order consumer, again, it takes a while. So this runs both the traditional tests against the address provider, but also the payment service client tests, which are used to test the integration with the payment provider. And now if I look at my contracts, it will have generated 2 contracts, because again, that order consumer does consume, it does depend on 2 providers, the address provider, but also the payment provider. And this payment provider order contract between the order consumer and the payment provider is completely generated based on the traffic that's going to and from this WireMock instance. So if I now tell it to again publish those contracts, it's going to publish 2 contracts. If I go to Pact flow again, you'll see that there will be an extra integration, a new integration, being one between the order consumer and the payment provider. It takes a while. Okay, I'll leave that in a moment. So this one is still okay. This one is still okay, but I've got a new one here. And that one is as of yet unverified. So this is a completely new integration. And again, this contract is not generated in the traditional way of using Pact and specifying Pacts and using those in tests. Now these are generated by just adding that extra listener to an already existing set of integration tests that use WireMock. Let me quickly start Postman, because I'm going to need that too. I have no idea why I shut that down in the first place. Because what I now need to do on the provider side, so it's no longer the provider's responsibility here to download that contract and verify it. No, it's the provider's responsibility now to upload its own version of a contract and have the Pact broker, or in this case Pact flow, check for compatibility. So the way to do that, as of now, is by sort of kind of doing that by hand. So Pactflow has an API that you can use to upload these things. I've already prepared the API call here. So this goes to my provider. So it's a provider contract for the payment provider, and more specifically for version 100 of that payment provider. And in the body, that's the most interesting thing here, is a base 64 encoded version of my contract when I say my contract, I mean this open API specification. And so again, this is something that most APIs will already have. So for the provider side, there's really nothing they need to add or do, no libraries, no dependencies, nothing. All they need to do is maybe add a step to their build pipeline that publishes the contract through an API call to the Pact broker. So what I specify here in this put request is the contract itself, the contract type, which is OAS, Open API specification, it's YAML, and some additional verification results. So this is a summary of the test results done on the provider side. So in this case, I've just put some nonsense in there. It's just plain text, and that's it. And if I send this, so and now, and it says that it's created, and you see some results created at the timestamp and some links that I can use, but I don't really need those links, because if I'm now refreshing this, again, this is uploading the contract from the provider end, we'll see that this previously unverified bidirectional contract is now, wait for it. Wait for it a little more. There we go. It is now successfully verified. And if I look at the contracts, I see I've got this, my provider version and the contract comparison, and some details about the consumer contract and the provider contract. And the comparison status is, well, those two contracts, so the contract generated from these WireMod-based tests by the consumer that was uploaded to the Pact broker, and the provider contract, basically Open API specification, they are compatible, meaning Pact Flow tells you there are no, I have not identified any potential integration issues. Just because we can, because we've got a couple of minutes left, let's make a quick change here. So what I'm going to change is that the status, instead of a string, is going to be a number. And as an example as well, so this is more like a status code instead of a status description, for example. So I've got my new contract here. So maybe then this is a provider side change that has been implemented. Copy and paste, because I quickly need to re-encode this. There we go. So this is again the base 64 version of that contract. Going to replace the existing one. Paste with this new contract. Provider side verification results have not changed, but this is a new version of the provider. So they've changed something. It's a new version of the contract, new version of the provider. Then that also created. And if I refresh once again now, it will tell me that there's a mismatch now between what Pact Flow has seen from the consumer side contract, which definitely depends on, so if we quickly look at the tests, it definitely depends on the status being a string. But now on the provider side, that status is an integer, meaning there is now a failure in the verification. So again, Pact Flow does the comparison between the consumer contract and the provider contract. It has spotted a new version of the provider contract for provider version 101. And it now tells you what the response body is incompatible, and more specifically around the status field in the body of the response. Where in the consumer contract, it expects something that looks like this, or rather a string, the provider contract says, well, it's not compatible, because that actually specifies an integer. And this is how bidirectional contract testing works. Again, there's no need to do a full-blown implementation of Pact here. You can leverage a lot of existing technology. Let me see if I can quickly bidirectional Pact. There we go. Let's have a quick look at the Pact documentation. To give you an idea of the kinds of technologies that are supported here. So what I've used is, on the consumer side, I've used WireMock. And on the provider side, I've used the Open API specification. But as you can see from the examples, there's also Knock, which is a JavaScript mocking library. You can use Cypress, which I think is very powerful because a lot of teams are using Cypress these days. Mountimag is also a mocking tool, mocking library. Same goes for Mock Service Worker. There's Dread, there's Postman that's supported for the provider side. Rest Assured as well, and Schema Thesis. And what has not been added here yet, but it's a recent addition to the family of tools that support, is the C# implementation of WireMock. So there's WireMock is originally a Java HTTP mocking library, but there's also a C# version. And as of a couple of weeks ago, that also supports adding a listener, generating a contract, and using that as the input for typically the consumer side, the consumer part of the bidirectional contract testing flow. So yeah, that's how bidirectional contract testing works. Again, it requires a lot less work to implement because it leverages existing tests, existing technology, existing specifications, which for a lot of teams takes away the hurdle of the traditional way of implementing consumer-driven contract testing. Some links that might be useful for you. This is the feature announcement, blog post by Matt, one of the core developers of Pact and Pact Flow, where he explains the idea behind bidirectional, the problems with consumer-driven contract testing, and the idea behind bidirectional contract testing. This is the landing page on the Pact Flow website, but it has a lot of useful links. And again, I've written a blog post series myself on contract testing, and the final article talks about bidirectional contract testing as well. It shows you the same example you've just seen in live demo. All of the code that you've seen, and especially the version of the code, including the bidirectional examples, can be found on GitHub. So if you want, but the articles that said that the blog post will also have links to those GitHub repositories. So if you want to have a look, if you want to see a working example, feel free to check it out. That's it for me. I think that's nicely on time. So 45 minutes. So we got 10-15 minutes left, which we can use for the Q&A.
Yeah, Bas, thank you. So a lot of details. So we have a couple of questions in a group chat. So if you can go ahead and
oh yeah, absolutely. I'll quickly stop
the questions one by one. That would be nice.
I'll just start from the top. Ivan Dimitrov asks, how would that work with GraphQL mutations? The schema might not change between updates. Also, the versioning of the API is different. That is a really good question. So in this case, the only contract that you've got is, and especially from a provider point of view, is that schema typically, or precisely, that's a typical, that's a typical provider-based contracts that you would use for you. With GraphQL, as you said, the schema might not change. It's more of the implementation behind that. I don't know too much about the versioning of the APIs, how that works with GraphQL, to be honest. But it might just be that it doesn't work as easily for GraphQL APIs. Absolutely true. Stephen asks, may you put that GitHub link here in the chat? Of course, I am more than happy to do that. Assuming you talked about the link to my repository. There you go. And then Curtis had quite a few questions. Awesome. I like that. If contract testing is so closely tied to the implementation, does it require a lot of maintenance while the product changes? Yes. The trick is to to minimize the coupling between the expectations that you've got, that you define, either in your tests or through your traditional consumer contracts, and the implementation. Because the closer that tie is, the more maintenance it will require. Absolutely. So I think this is kind of similar, but as to what people typically preach when they talk about writing unit tests. So the closer your tests are tied to the implementation, the more work it will be to update them. So a good unit test tests behavior and not implementation. And I think with contract testing, it's much the same. Really, so really tie that to the behavior and not so much to the implementation, and that will definitely reduce the maintenance that will be required. Next one is bidirectional contract testing on the roadmap for Docker-based Pact broker. Unless the people behind Pactflow have changed their mind, no. So this is their way to make some money out of all the work that they do, and that's one of the motivations. So definitely for the foreseeable future, it's going to be Pactflow, which may be a challenge of its own for people, but that's the latest that I know of, is that they're going to keep this Pactflow only. For the auto-generated contracts, would we want to take the generated contracts and write them out as a normal Pact test in the long run? Can you give me an example of that, Curtis? I don't know if you can unmute yourself and give an example, just give me a little bit of context there.
Yeah, I'm just thinking, the auto-generated contracts, I imagine that they might be a little too tied to the implementation, like you said earlier, and maybe be a little over-specified. And as the product changes, I wonder if it would be better to have that, have the contracts set out explicitly in the the more traditional Pact tests.
Yeah, and I think, are you reasoning from, I think you're, and please correct me if I'm wrong, mainly talking about the consumer side of things?
I don't know. Yep. I think I'm thinking of it more from the provider side.
So because this is at the traditional way of consumer data, the biggest challenges are typically found at the provider side. And because they say, well, we've got these contracts already, so it's harder to get them on board. And it's also almost started mentally harder for them, because it's all these consumers that tell me what I am supposed to be doing. But write them out as a normal Pact test in the long run. So the good news is, because the answer is probably going to be it depends, and I hate that answer. The good thing is that the two ways are not mutually exclusive. So you can have a consumer-generated contract that's generated in the traditional way, and so using Pact, and have that matched by, for example, an open API specification from the provider side. So that's possible. Is this for a lot of again would take at the end? It depends. It's probably the best answer that I can give. And again, I hate that answer, because there's a lot of
That's fair.
Yeah, a lot of context and stuff that plays a role. But it's a very good question. Francesco, you added allow some form of semantic testing. You test scenarios with preconditions and expectations. That is absolutely true. Davi, how do you handle backward compatibility if you have multiple versions of an API live at one time? So a contract is tied to a version of an API. And so the same API, the same consumer provider can have different contracts tied to different versions. And these Pact brokers, they can do versioning. So they can.
Your test now still had versions 1.00 live. So 1.00.
Yeah, because it takes, the consumer version did not change. That's true. Yes. But that's because I've been lazy, and because it pulls that consumer version info from my project from a Java project definition, and it didn't update it there. So what you would typically do is with a new consumer implementation, you would update the version number, which marks it as a new version of the contract at the broker, and the broker can then tell you not just is this consumer able to communicate with the provider, but also this version of the consumer is compatible with this version of the provider, and not maybe with the future version.
Okay.
So it can do that. So yeah, that's again, I've been a little lazy there with my consumer side kind of things, but it basically in my projects in the code for the Java bindings, it basically pulls it from the POM file or from your Gradle file if you use Gradle. Francesco, he said, with BDCT, are you testing only the structure of the response and the types of values? Yes, but that's also true for contract testing in general. So you verify shape, you don't verify values, because that's crossing the line between compatibility between a consumer and a provider and the business logic that you've implemented at the provider side typically, and that's not the responsibility. Again, typically, often in practice, unfortunately, it turns out that the consumer is responsible for it, but it shouldn't be. So it should be the provider's responsibility to test its own business logic. And what's then left for contract testing is, again, are those consumers and providers able to talk to one another? So with contract testing, I would focus only on shape and structure and not on actual values, or at least as little as possible, because again, if you do, you get a lot of tight coupling between your consumers and your providers, which doesn't scale very well, let's put it mildly. Lots of good questions. So again, I hope that answered your next statement as well. Some form of semantic testing. Yes, you can do that, but again, the tighter the coupling, the worse it scales. Since the Raja, you asked, since the validations are carried out on Pact flow, yeah, how can we handle strict type validations? So to some extent, Pact flow does that. As you saw in the example, in the last example, where I changed the data type of a field in the provider side contract specification from a string to a number. And you saw that Pact flow signaled that there was a mismatch between what the consumer expects based on what they are testing for in their tests that use WireMock, which is used to generate the consumer side contract, and the specification, the contract that the provider uses, the Open API specification. So it saw that there was a mismatch between, well, my consumer, based on what I see in their tests, they expect that status code, that payment status code, to be a string. But according to the contract from the provider, it's going to be a number. So there's a mismatch. So it detects those type validations. Unless that's not the answer that you were looking for, in which case, can you give me an example?
Yeah, I think I got the answer for my question from your explanation to Francisco. So my question was also kind of similar to handling the structure of the response and types of values. So
awesome.
Yeah, thanks.
Thank you.
Yeah.
I think we've covered. That means we've covered most of the questions, if not all.
Yeah, but so those were the good questions. So we completed we covered, I think, all of the questions that addressed to the group chat. And I think we also pretty much at our time frame right now. So, Bas, before we end up the call, do you have any, you want to share any details about your professional work?
Yeah, no, very good. Again, I work for together with a fantastic team of people at Inspired Testing at the Inspired Academy. Don't laugh, Dawi, you're one of them. And now this is going to end up on YouTube.
Yeah,
Gary said it. No, yeah, we do lots of good things. So Inspired Testing is a software testing services provider. I head up a branch of that, or a business within a business that is solely responsible for training. So yeah, we do a lot of training, including on contract testing, on API testing in general, but also on a wider spectrum of skills in software testing and automation. So anywhere from introduction to automation, to just object-oriented programming, to API testing, to behavior-driven development. I'd say, yeah, check out Inspired Testing and the Academy and all of the good things that we're doing over there.
Yeah, and also our attendees can find the complete overview of professional life on your LinkedIn profile as well.
Oh yeah, absolutely.
And yeah, this was such a great presentation, Bas. Thank you so much. And as I mentioned, we are pretty much at our time. And unfortunately, that's all the time we have today for this session. I would like to thank you again, Bas, for your time and expertise.